Alright, let's look at the practice exam 2, problem number 9. Alright, so we want to first sketch the region D. Alright, so let's do that. Alright, so integral inside is with respect to y. So we know that this is equal, this is y equals square root of x, and this is y equals 2. Alright, so let's sketch the y equals square root of x. So it's just going to look like this, right? So it's going to look, so start from the origin, and it's going to look like that, right? Then y is going from square root of x to 2, and the 2 seems like it's a 2 is right here. So y equals 2 looks like this. So the region we're talking about is, let's see, it's going to be 0 to 4. Actually, I messed it up a little bit here. Right, this actually goes through here and then hit here. Right, so then y equals 2 is this horizontal line here. So the region we're talking about is this region right here. All right, so so that's the region, and let's see, x is going from 0 to 4, so that's right? All right, then reverse the order of integration. So we want to do it with respect to x first, right? So here, so this the y-axis is x equals 0, right? Then this guy is, we said that the y equals square root of x. But we can just square both sides so that we can write it as y squared is equal to x. So we know that if for a fixed y value, maybe I'll use this, for a fixed y value, right, x is going to go start from x equals 0 all the way to x equals y squared. So we know that x is going to start from 0 to y squared, right? And once you've done that, we have to cover the entire region. So starting from here, which is y equals 0, then increase the value y all the way to here, y is equal to 2. So we know that y goes from 0 to 2. Right, so that's part B. Right, then we just have to evaluate this. Right, so this is going to be equal to. Right, so I'm going to leave the outside integral for now here. Right, so dy. Then try to find the antiderivative. You can see that the 3 over y cubed plus 1 has nothing to do with x. It's just going to be a constant. So I'm going to put it outside of the inside integral. So you have a y cubed plus 1. Alright, then you are integrating 1 with respect to x. So it's going to be x. Then you're going from 0 to y squared. Right? So this is going to be integral from 0 to 2. Alright, plugging y squared and 0, so you get y squared. So you're going to have 3y squared over y cubed plus 1 with respect to y. Alright, you notice that the numerator is exactly the derivative of the denominator. So antiderivative is going to be natural log of absolute value of the denominator. So y cubed plus 1. And then you're going from 0 to 2. Right? So if you plug in 2, you get the natural log of 2 cubed, so 8 plus 1. So it's a natural log of 9 minus natural log of 1. right? But we know that the natural log of 1 is actually 0, so we get natural log of 9, right? So that's why we have a natural log of 9 as the answer. All right, that's it. I hope that this was clear.